Hi everyone, and welcome to this tutorial series where I will show you how you can create this simple multiplayer game with Godot and Firebase. In this video series, I will guide you step by step through the project and teach you everything you need to know to get started. You can also find the written version of this tutorial series in the video description. In this first video, we are going to set up the Godot and Firebase project. At the end of this first part, we will be able to send our player data up to Firebase. Let's get started. In a fresh Godot project, we can start by creating a root 2D scene node. We'll call mine world. Let's add our local player as a character body 2D node. We'll give the player a sprite 2D and a collision shape 2D. For the sprite 2D, we can use the Godot icon for now. For the collision shape, let's define a rectangle. Now we can save the scene. I always like to keep my project hierarchy clean, so I'll create a folder for scenes. And here we can save the world.tscn. Now to make our player move, we first need to define an input map. Go to project, project settings, input map, and here we can create 4 new actions for each of the movement directions. Move up, down, left, move right. Now for each of these actions, we can define controls. I'm just going to define the WASD and the arrow keys. Now let's make our player move. I'm going to rename the node to player local. Now let's add a script to our player to move him around. Remove all the boilerplate code and start by defining a constant movement speed. In the physics process function, we can get our horizontal and vertical movements from our input map by defining 2 axes. For the horizontal movement, the move left is the negative action and move right is the positive action. Similarly, for the vertical movement, the move up action will result in negative dy values and the move down in positive dy values. To calculate a 2D movement direction from this axis, we can create a normalized vector 2D, which will have length 1 and point in the correct direction. That way, we will always move the same speed, even when moving diagonally. However, we can only normalize the vector if it's not 0. Otherwise, we would divide by 0. Finally, we can call the move and slide method from the character body 2D to make our player move with the desired velocity while respecting collisions. So now let's run our project. The first time you run a Godot project, you're always prompted to select the main scene. Since we already have our world scene open, we can select current. And here you go. Can move the player around with the WASD keys or the arrow keys. And now that we have our player movement working, we can start working on synchronizing our local player with Firebase. But first, let's add 2 more variables to our local player script. A random 6-digit integer number for the player ID and a random player color. To generate a random color, I am using the HSV color space, which defines colors not based on RGB values, but instead with a hue, a saturation, and a brightness value. This has the advantage that we can generate different colors with the same brightness and saturation. In the next step, we will create a separate node that handles the synchronization of our local player with Firebase. To reference our local player variables in the other script, we want to make sure that we add a class name to this script first. Now we can work on the synchronization script, which will continuously send our local player data to Firebase using raw HTTP requests. Create a new HTTP request node and add a script to it. The first thing we need to define here is a reference to our local player node. Because we added a class name to our script, we can add the type for player script and export the variable to make it accessible in the editor. In the inspector of our HTTP request node, we can now assign the player by dragging the node onto the exported variable field. Let's create a function to send our local player data and call it continuously every frame. However, we don't want to spam the Firebase server with requests every frame, while our previous request might still be pending. Therefore, we need to keep track of whether a request is currently pending in a variable and reset it once a request has completed. In the ready function of our script, we can connect the request completed callback to a new function where we can reset our request pending state. We also want to print any errors if the request didn't succeed. In the send function, we can define our player data in a dictionary containing the player ID, the 2D position, and the player color. To serialize our player color, we use the toHTML method. This will return our color converted to an HTML hexadecimal string. By passing with alpha false, we exclude the alpha value. The player data is then parsed to a JSON and sent to our Firebase Realtime DB endpoint. This Firebase endpoint URL we have yet to create. Open up a browser and go to the Firebase website. From here, you can open the console and create a new project. Once you've created your project, go to Build, Real-Time Database, and create your database. Make sure to select the test mode in the security rules. This will automatically generate our read and writes to the real-time database for the next 30 days. After prototyping your project, you should restrict the access by only allowing authenticated users to access the database. However, for now, we can leave this setting in test mode. Now you should see an empty real-time database with a URL. This is the endpoint we need to add to our script. Copy the URL and go back to the Godot project. At the top of the script, I will add the host URL as a constant. In the send function, we can now define the final URL by combining the host and root to our player. This will create a tree structure in the database, where all players are inside the players directory with their respective player ID and then the data attached to them. Let's also extract this URL composing into a function to keep our code well structured. Let's add a small optimization to this by not sending the same data over and over again. We can store the previously sent player data in a variable, and before sending a new request, we check if the data has changed. If not, we're not sending a new request. Now if you open the Firebase database and the game side by side, you can see our local player being added to the real-time database and updating the position whenever we move. One thing you will notice is that the player stays in the database even when we close the game. To fix that, we can send a delete request when we close the game. To modify the exit behavior of our Godot application, we can set the auto-accept quit to false in the ready function. Now we can add custom application quit logic in the notification method when we get a close request. Create a delete local player function that will be called whenever we receive a close request notification. In the function, we generate our player URL, cancel any pending requests, and then send a new delete request to the generated URL. We wait for the request to be completed, and finally we can quit our game. Now you can run your game again, and if the game is closed, you will also see that the entry in the database is cleaned up. We're getting some errors because we forgot to add the check in the process function to only send new requests when the old one is completed. So here in the process function, make sure to only send a new request when the old one is completed. Now the errors should be gone. Alright, so this is it for the first part. Stay tuned for the next parts, where we will work on getting other players to show up in our game, as well as improving the visuals. Make sure to check out the resources in the description down below and comment if you are having any issues when setting up your project. I'm happy to help. Anyways, I'll see you in the next video. Take care.